How we doing, guys? We're finally looking at some calculations in this chapter. We're on page 383 there, looking at question 3. This is measures of center, also known as sometimes measures of the location of the data, or the average of the data is another one you'll hear. An average, when we use it now, is a general term that refers to three specific things. One is the mean, which is what's often mixed up with the average. One is the mode and one is the median. Okay, you've met these for junior cert. Let's just dive in with question 3 and we'll see how it goes. A rugby team has 10 games played. Here are the number of points scored. Write down the mode. What is the median number of points? Find the mean number of points scored. Okay, so the first thing you need to do here is write out all of those scores in order. You can see here the first time I just made a mistake, so I've just written them out again. That's the 10 games, but they're written out in order, and this is always a pretty standard first step you're going to take. The mode then that they've asked for, well, that's the most common element in any set. And you can see here the most common result that this rugby team had was 14 points. So there's your answer to the first one. The median in a set is the middle value in an ordered set. So an ordered set is what I've done up here. You've put all the numbers in order. Now I've got 10 numbers here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's a strong case that either of these numbers are the middle number, okay? And when that happens, look, you've got 4 below and 4 above. You want to try and split the difference. Now, splitting the difference here, it's still just going to be 14, but the procedure is add them together and divide by 2. And you get 14 here, okay? And what you get then is a median number here of 14, where half of the numbers, 5 of them are bigger, are smaller, and half of them will be bigger, okay? And that's what you're aiming to do, split a data set in half with the median. It's the middle value in an ordered set. The mean is the one you're used to maybe the most, which is add them all together, divide by the number of numbers you have. So the sum of the elements divided by the number of elements. So we're going to be dividing by 10 here, and it's 7 plus 11 plus 12 plus 14 plus which is 170 divided by 10. 17 points is the mean. So these are the three different averages. You can see 14 points, 14 points, and 17 points. And they all have strengths and weaknesses. The mode, very easy to calculate. You can spot it very quickly. And in a kind of, in most distributions, the mode is around what's called the center of the data. These are all trying to measure where is the center of the data. What's a good number to represent these 10 numbers on average is really what we're looking for. The median is always, by definition, I suppose, at the center of the data. It ignores very high values and very low values, and it gives you a good kind of middle ground. The mean has this advantage that it takes every data point into account when you do it, but it can be thrown out by unusually high numbers, which are sometimes called outliers. Now, this isn't crazy high, that 36, but it might be called an outlier, that it's an unusually high number in the set. And the mean can be skewed by having very large or very small numbers. So by having outliers is one of the disadvantages of working with the mean. If we have a look at question 6 here, you can see they say find the mean and then find the median and say which of these two averages best describes the numbers. And you can see here there's a very clear outlier of 100 in this data set. It's an unusually large number by comparison with the rest of the set. So, well, let's work out what's the mean first and then what's the median. You can see here the mean, when you add them all together, you get 181 divided by the 7 numbers. So you divide by 7, you get 25.9, 26 nearly. Which, if you look, it's not really a good representation of any of the numbers in this list. I mean, these are all clustered around something smaller, and then the 100 is what dragging up or skewing the mean. The median then, well, you've got 1, 2, 3, 4, 5, 6, 7 numbers in order. So there's the bottom 3, there's the top 3. The middle number there is 15, is the median. That's probably a better representation, the middle number in that ordered set. It's ignoring that 100. And it's probably fair to say most of those numbers are close to 15, with one exception, whereas none of those numbers are really close to 26. So it's probably a better representation. It's not skewed by that one big outlier. Question 12 then gives us this thing called a frequency table. Paula has 6 people in her family. She wants to know how many people are in her friends' families. She asks each of the friends and records this information. So here's the information. What you're looking at here, though, really is a list. Okay, and another way to write that information is like this list here. We've got 2 2s, 4 3s, 6 4s, 5 5s, 2 6s, and one person said they had 8 people in their family. So this is obviously, it's kind of harder to look at. It's if there was 1,000 pieces of data, this would be very awkward. Whereas the frequency table summarizes it very nicely once you know what you're looking at. Write down the modal number of people in those families. So the most common answer that Paula got here was, was 4 people in the family. Okay, 6 people gave that answer. And if we go back and have a look at what we had, that was 4 is kind of obviously the most common answer on this list. So to go back to our book, yeah, so the modal answer is 4 people in the family. The median number of people per family. Now that's nearly easier to do on our list layout, but let's have a look. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 people. So you'd say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We want to split that in half. Okay, there's the lower half, or the lower 10 people, and the lower 10 families, I suppose, in terms of numbers, and the upper 10. You can see the median here is going to be 4 plus 4 over 2 is 4. Now, how could you have done that straight off the frequency table? Well, again, you would have said, look, 2 plus 4, how many people did she survey? 2 plus 4 is 6, plus 6 more is 12, plus 5, 17, 18, 19. She surveyed 20 people. Where's the 10th person? Well, there's the first 2, if they're in order as they are. First 2, then the next 4 here, that's 6 people. So far here, 6 people counted, and then another 6 makes 12. So the 10th person is in this group somewhere. So that's where the median is going to be, and that answer is going to be 4. Okay, 4 people in that family is the median. Calculate the mean of the distribution. Again, going back to our list, maybe the easier way to do this is to say add them all up, 2 plus 2 plus 3 plus over 20. But again, if you've got lots and lots of numbers, that's a bit trickier. So how about this? You've got 2 2s, so you say 2 multiplied by 2, plus we've got 4 3s, so you say 3 multiplied by 4, plus we've got 6 4s, so you say 4 multiplied by 6, plus we've got 5 5s, 5 multiplied by 5. We've got 2 6s, 6 multiplied by 2, and 1 8, 8 multiplied by 1. And divide all that by 20. Well, if you look at what you have here, that's our number of siblings in each case, our number of people in the family, multiplied by the frequency on the frequency table in each case. Okay, so that's how you'll find the mean from a frequency table, which you can see there is 85 over 20, and that's 4 1/4 was the average number of people in a family, 4.25, which is fine for a mean, even though obviously you can't get 4.25 in any one particular family. It's fine to have that as your value. Okay, we'll wrap up with 13 here, which is the ages of some people watching the film are given in the frequency table. Now, you don't get the exact ages. There were 4 people between the ages of 10 and 20, 15 people between the ages of 20 and 30, 11 people between 30 and 40, and 10 between 40 and 50. So it says, use the mid-interval value of each class to estimate the mean of the distribution, giving your answer correct to the nearest year. So this is a class. 10 to 20 is one class, and the mid-interval value there would be 15. 20 to 30, the mid-interval value you can probably guess is 25. How you get these, by the way, is 20 plus 30 is 50, divided by 2 makes 25. So 30 plus 40 is 70, divided by 2 makes 35, but a lot of the time it's just kind of obvious, and this one's going to be 45. And you treat these 4 people as though all of them are 15 years old. You treat these 15 people as though all of them are 25 years old, these 11 people as though they're 35, and then you're working with the same type of frequency table that we saw in the last one. So to estimate the mean of this distribution, you're going to say, well, 15 multiplied by 4 The total age is 15 multiplied by 4 plus 25 multiplied by 15 plus 35 multiplied by 11 plus 45 multiplied by 10 divided by the total number of people, which is 4 plus 15 plus 11 plus 10. Okay. Okay, sorry about that. I don't think I was sharing the screen there. That's 13 there. And you can see I've put in those mid-interval values, 15, 25, 35, 45 in there. Okay, so calculating the mean of that set of numbers, you say 15, the mid-interval value multiplied by 4, the frequency. Okay, value multiplied by frequency, value by frequency, value by frequency, add them all together. Number of people surveyed, 4 plus 15 plus 11 plus 10. And what you have here is an estimate of the mean, because that 15, 25, 35, 45, those are estimates of the age. So just be a little bit careful about how much certainty you put onto this, that it's an estimate of the mean, not a definite mean. Okay, and what you get there is add all the ages up, you're going to get 1,270, or the approximate ages, divided by 40. 1270 divided by 40 gives 31.75 is an estimate of the mean value. The next part of that question then says, in which interval does the median lie? So again, how many people were surveyed here? 4 and 15, or well, we just looked at it, we saw 40 there when we had 4 and 15 and 11 and 10. So there's 40 people. We're interested in the 20th person. That's the median person in the middle, the 20th person. Well, there's the first 4 and there's the next 15. So there's 19 people in the first 2 sections here. So the 20th person is here in this interval 30 to 40. So the median lies within the 30 to 40 interval. Okay, so that's as much as we can say. The median is in the 30 to 40 years old interval. We don't know exactly where it lies, although being the 20th person, you might guess that it's at the lower end of that 30 to 40 interval. But you can't say really with any certainty. Okay, so as well as making sure you have questions 3, 6, 12, and 13 taken down in your copy, can I ask you to go now and do questions 1, 2, and 11? All right, see you next time.